Hello everyone, welcome to the course on Introduction to Electric and Hybrid Electric Vehicles. So dear learners, in today's lecture, we are going to discuss a very important aspects in the sector of electric vehicles, that is the role of artificial intelligence in EV sector, and also we will discuss about the concept of vehicle to everything in electric vehicles. So learners, let's start the lecture. So artificial intelligence has revolutionized numerous sectors and the automotive industry is no exception. Among the most notable developments in this field is the integration of AI into electric vehicles. So dear learners, in this lecture, we will explore the multifaceted role of AI in electric vehicles, focusing on key areas such as autonomous driving, battery management, energy optimization, predictive maintenance, user experience and the future of transportation. So let's start with autonomous driving. So one of the most profound impacts of AI on EV is in the domain of autonomous or self-driving cars. AI algorithms, particularly those based on machine learning and deep learning, enable electric vehicles to navigate complex environments without human intervention. So in this we will cover computer vision and sensor fusion. So autonomous electric vehicles rely heavily on computer vision and sensor fusion to interpret their surroundings. Cameras, LiDAR, radar and ultrasonic sensors provide vast amount of data which AI algorithm process in real time to identify objects, road signs, pedestrians and other vehicles. Deep learning models such as convolutional neural networks are particularly effective at recognizing and classifying images, allowing EVs to make split-second decisions based on their environment. Next is path planning and decision making. So AI plays a crucial role in path planning and decision making for autonomous EVs. Using reinforcement learning, a subset of machine learning, vehicles learn from various driving scenarios to make optimal decisions. These decisions include lane changes, acceleration, braking and navigating through intersections. Over time, the system improves by learning from both simulated environments and real-world experiences, thereby increasing the safety and reliability of autonomous EVs. Safety and redundancy. So AI enhances the safety of electric vehicles through advanced drive assistance system, particularly known as ADAS, which is in particular in working in the current vehicles, which is of level 1, level 2, level 3 based upon the features. So features like automatic emergency braking, adaptive cruise control, lane keep assistance and blind spot detection are powered by AI algorithms. These systems not only improve the driving experience but also significantly reduce the likelihood of accidents. Moreover, AI-based systems incorporate redundancy, meaning that multiple algorithms cross-check each other's decision to avoid errors, thus ensuring a higher level of safety. Second one is the application of AI in battery management and optimization. So battery efficiency is a crucial aspect of EV as it directly affects the range, performance and overall cost of ownership. AI is pivotal in optimizing battery usage, extending battery life and predicting when maintenance or replacement is needed. So under this, battery health monitoring is done by the AI. So AI models can predict the state of charge and state of health of batteries with high accuracy. Machine learning algorithms analyze historical data to understand how different driving patterns, temperatures and charging cycle affect battery life. This allows for proactive management of battery health, alerting users when their battery is degrading or when it requires servicing. Next one is energy management systems. So electric vehicles require efficient energy management systems to balance power distribution between various vehicle components such as the motor, battery, air conditioning and infotainment systems. AI-based algorithms optimize this power distribution, maximizing the range of the vehicle while ensuring a comfortable driving experience. These algorithms can adapt to real-time conditions such as traffic, weather, and driving style to make dynamic adjustments that conserve energy. Next, we will discuss smart charging. So, AI enables smart charging solutions that are essential for optimizing both the cost and efficiency of charging EVs. Predictive analytics can be used to determine the best time to charge based on electricity prices, grid demand, and the vehicle's usage pattern. Moreover, AI algorithms can enable vehicle-to-grid V2G systems where EVs not only consume power from the grid but also supply power back during peak demand, helping stabilize the grid while providing economic benefits to vehicle owners. So, next we will discuss with the predictive maintenance. So, predictive maintenance is a key area where AI adds value to EVs by analyzing vast amounts of data generated by vehicle sensors. AI algorithms can predict potential component failures before they occur. So, let us discuss with the real-time diagnostics. So, EVs are equipped with numerous sensors that monitor various components' performance from the battery and motor to the brakes and suspension system. AI algorithms analyze the data from these sensors in real time to detect any anomalies that could indicate wear and tear or potential failure. This real-time diagnostic capability allows for timely intervention, reducing the risk of breakdowns and improving vehicle reliability. Maintenance scheduling. So, AI-driven predictive maintenance systems can recommend optimal maintenance schedules by analyzing usage patterns, driving behavior, and historical maintenance records. This prevents unnecessary maintenance tasks, saving both time and money for vehicle owners. Furthermore, it ensures that all critical components are maintained in optimal condition, thus extending the lifespan of the vehicle. Next one is remote software updates. So, EVs are increasingly becoming software on wheels, with many components controlled by software rather than purely mechanical systems. So, AI algorithms can identify software related issues and suggest or even implement over the air OTA updates, like we get the OTA updates for our mobile. Likewise, for vehicles also there is the update in over the air manner or over the air fashion to resolve the issues of electric vehicles. This ability to remotely update software ensures that vehicles are always running the latest, most secure and most efficient version of their operating systems and applications. Next is the role of AI in enhanced user experience. So, AI is at the heart of transforming the user experience in electric vehicles, providing personalized, seamless and intuitive interactions. So, in this, first of all we have natural language processing and voice assistants. So, AI driven natural language processing NLP enables more intuitive voice commands and interactions with EVs. Users can control various aspects of the vehicle such as navigation, climate control and entertainment simply by speaking, like Alexa or the Google. So, these are all the natural language processing softwares. So, advanced voice assistants powered by AI are capable of understanding context and natural speech patterns, making them more user friendly and efficient. Next is personalized driving experience. So, AI can learn a driver's preferences such as preferred routes, driving style and comfort settings. By analyzing this data, EVs can provide a highly personalized driving experience. For example, the vehicle can adjust seat positions, temperature, music preferences and even driving modes based on the user profile. Next one is advanced infotainment system. So, modern electric vehicles come equipped with advanced infotainment system that use AI to enhance user engagement. These systems can recommend music, news and other content based on the user preferences and habits. Additionally, they can provide real-time updates on traffic, weather and charging station availability, ensuring a more informed and enjoyable journey. So, next we will discuss the role of artificial intelligence in energy efficiency and route optimization. So, AI plays a significant role in improving the energy efficiency of electric vehicles through smart route planning and energy management. Route planning and traffic management. So, AI powered navigation systems can analyze real-time traffic data and suggest the most efficient routes to minimize energy consumption and travel time. These systems consider factors such as road conditions, traffic density, elevation changes and even the proximity of charging stations. By avoiding congested routes and planning efficient trips, AI helps maximize the range of electric vehicles. Next one is eco-driving modes. So, AI algorithms can automatically adjust driving modes to optimize energy usage based on driving conditions and patterns. For example, in heavy traffic, the system may switch to an energy saving mode, reducing the power sent to the motor and other non-essential systems. This intelligent adjustment helps conserve battery life and extends the vehicle's range. Next one is the regenerative braking. So, regenerative braking system, a hallmark of electric vehicles, can be optimized using AI. These systems capture and store energy that would otherwise be lost during braking. AI algorithms can predict when and how to engage regenerative braking to maximize energy recovery and enhancing overall vehicle efficiency. So, this is regarding the energy management system. Next, we will discuss the future of transportation, AI and electric vehicles. So, what are the technology or the development will come in the near future? So, the integration of AI in EVs is paving the way for the future of transportation. The combination of AI and EV technology is not just limited to private cars but extends to public transportation, shared mobility and even freight logistics. So, first of all, we will discuss the autonomous electric fleets. So, the future of transportation is likely to be dominated by autonomous electric fleets managed by AI. These fleets could serve as public transport or ride-sharing services, reducing the need for private car ownership and helping to decongest cities. AI would be responsible for managing routes, schedules and maintenance, ensuring that these fleets operate efficiently and safely. Next one is smart cities and connected ecosystems. So, the AI enabled electric vehicles will be a critical component of smart cities. Connected to city infrastructure and other vehicles, these EVs can communicate in real time, enhancing traffic flow, reducing congestion and lowering emissions. AI driven systems will coordinate traffic signals, optimize parking and provide smart charging solutions, all contributing to a more sustainable urban environment. So, the next is advanced battery technologies. So, AI is also driving the development of next generation battery technologies such as solid state batteries and supercapacitors. By analyzing vast data sets from battery research, AI can accelerate the discovery of new materials and optimize battery designs. This will lead to more efficient, safer and longer lasting batteries, which are crucial for the mass adoption of electric vehicles. Next is sustainability and environmental impact. So, AI in electric vehicles plays a vital role in promoting sustainability. Electric vehicles are already more environmentally friendly than their internal combustion engine counterparts. However, AI further enhances their eco-friendliness by optimizing energy usage, improving battery life, and enabling sustainable practices like V2G or vehicle to grid. These advancements contribute to reducing the carbon footprint of transportation, aligning with global sustainability goals. So, these all are the application or the involvement of artificial intelligence in the coming future in the transportation sector, particularly in the electric vehicle domain. So, this is all about the role of artificial intelligence in electric vehicles. Now, dear learners, we will discuss a very important aspect of the electric vehicles, which is the concept of vehicle to everything or V2X. So, the concept of vehicle to everything or V2X in EVs represents a new frontier in smart mobility, transforming how vehicles interact with their surroundings. So, V2X refers to the communication system that enables vehicles to exchange information with various entities including other vehicles defined as V2V, infrastructure, pedestrians and the grid. So, the goal of V2X is to improve road safety, traffic efficiency, energy management and overall driving experience by leveraging real-time data exchange. So, V2X encompasses several sub-concepts such as vehicle to vehicle represented by V2V, vehicle to infrastructure represented as V2I, vehicle to pedestrian denoted as V2P, vehicle to network represented as V2N and vehicle to grid which is denoted as V2G. Each of these sub-concepts serve as a specific purpose and collectively enhances the capabilities and benefits of electric vehicles. So, in this comprehensive discussion, we will explore the various components of V2X and their applications in electric vehicles. So, first of all, we will discuss about the overview of V2X communications. So, V2X communication is an umbrella term that includes different types of vehicle communication, all of which aim to create a safer, more efficient and interconnected transportation ecosystem. So, V2X uses various communication technologies including dedicated short range communications DSRC, cellular vehicle to everything CV2X and increasingly 5G networks. These technologies enable low latency, high reliability communication between vehicles and their environment. So, the key components of V2X. So, first one is the vehicle to vehicle. So, communication between vehicle to share information about speed, location, direction and other data to avoid collisions and improve traffic flow. Next one is the vehicle to infrastructure. So, communication between vehicles and road infrastructure such as traffic lights, road signs and toll booths to enhance traffic management and safety. Next one is vehicle to pedestrian. So, communication between vehicles and pedestrians or cyclists, enhancing safety by alerting drivers or automated systems of potential collisions. Next one is vehicle to network. So, communication between vehicles and the cloud or other networks for information like traffic updates, weather conditions and navigation. Next one is vehicle to grid denoted as V2G. So, communication between vehicles and the power grid to enable two-way energy exchange, optimizing energy usage and grid stability. So, next we will discuss about the vehicle to vehicle communication. So, V2V communication is a critical component of V2X that enables vehicles to exchange information with each other in real time. For electric vehicles, V2V communication can provide multiple benefits particularly in terms of safety, energy efficiency and autonomous driving capabilities. So, first of all, we will discuss about the safety applications. So, V2V communication improves road safety by allowing vehicles to share information such as location, speed and direction. These enable features like collision avoidance systems, emergency braking and lane change warnings. For instance, if an EV detects a sudden braking event ahead, it can immediately alert nearby vehicles to slow down, reducing the risk of a chain collision. Next one is platooning. So, platooning is a concept enabled by V2V communication where a group of vehicles travels closely together in a coordinated manner, reducing aerodynamic drag and improving fuel efficiency. For electric vehicles, platooning can extend the range by reducing energy consumption. It also allows for more efficient use of road space, decreasing congestion and improving traffic flow. Next is autonomous driving. So, V2V communication is essential for the advancement of autonomous electric vehicles. It allows autonomous EVs to share sensor data such as camera and radar information to build a comprehensive picture of their surroundings. This collaborative approach enhances the decision-making capabilities of autonomous system, leading to safer and more reliable self-driving EVs. So, learners, now we will discuss about the concept of vehicle to infrastructure communication, denoted as V2I. So, V2I communication involves the exchange of information between vehicles and road infrastructure, enabling a more connected and intelligent transportation system. So, in this we will first discuss about the traffic signal optimization. So, electric vehicles equipped with V2I capabilities can communicate with traffic signals to optimize their driving patterns. For instance, if an EV knows that a traffic light will turn red shortly, it can adjust its speed to avoid unnecessary braking, thus saving energy. This optimization can improve traffic flow, reduce congestion and enhance overall road efficiency. Next one is smart parking. So, V2I communication can assist EVs in locating available parking spaces by interacting with smart parking infrastructure. This reduces the time and energy spent searching for parking spots, improving the overall driving experience. In addition, it can integrate with smart city infrastructure to offer dynamic pricing based on demand and availability. Next one, we will discuss about the road hazard warnings. So, the V2I communication can alert EVs to potential road hazards such as construction zones, accidents or slippery conditions. This information enables the vehicle's advanced driving assistance system known as ADAS to take preventive measures such as reducing speed or changing lanes, thereby enhancing the safety. So, next we will discuss on the dynamic charging management. So, the electric vehicles V2I communication can be crucial for managing the charging stations also. It can provide real-time updates on charging station availability, waiting times and charging costs, allowing drivers to make informed decisions on where and when to charge their EVs. This dynamic management helps balance demand at charging stations and reduces the waiting time. Now, next is vehicle to pedestrian communication, V2P. So, the V2P communication enhances the safety of vulnerable road users such as pedestrians and cyclists by allowing direct communication between vehicles and individuals. So, in this First one is the pedestrian safety alert. So with V2P communication, EVs can detect the presence of pedestrians, especially in situations where visibility is limited, such as at the night or in adverse weather conditions like in foggy or smoggy weather. It can also function quite well. So the EV can alert the driver or activate automated emergency braking if a collision is imminent. This is particularly valuable in urban areas with high pedestrian traffic. Next one is cyclist awareness. So similar to pedestrian safety, V2P communication can enhance cyclist safety by alerting drivers to the presence of cyclists in blind spots or when making turns. So the EV can also communicate with cyclist smartphones or wearable devices to provide warnings about approaching vehicles, creating a safer environment for all road users. Next one is integration with smart devices. So V2P communication can be integrated with smartphones and other wearable devices carried by pedestrians and cyclists. These devices can send signals to nearby vehicles, alerting them to the user's presence. This proactive approach helps prevent accidents and enhance the safety of vulnerable road users. So next is vehicle to network communication. So V2N communication connects vehicle to cloud-based services, enabling them to access real-time information and deliver data to a centralized network. This communication type is essential for various applications in EVs. So first one is the real-time traffic information. So V2N communication allows electric vehicles to access real-time traffic information from centralized servers or cloud networks. This data helps EVs to select the most efficient routes, avoiding congested areas, accidents or road closures. Efficient route planning not only saves time but also conserves battery power, extending the range of electric vehicles. Next one is weather updates and hazard warnings. So access to real-time weather data allows EVs to adapt their driving strategies based on current conditions such as rain, snow or fog. V2N communication can also provide hazard warnings such as landslides or floods, allowing drivers to make safer and more informed decisions. Next is cloud-based navigation and infotainment. So the V2N communication enables electric vehicles to offer enhanced navigation and infotainment services. Cloud-based navigation systems can provide turn-by-turn directions, points of interest and charging station locations, while infotainment systems can stream music, podcast and news. This connectivity improves the overall user experience, making EVs more appealing to tech-savvy consumers. Now the next is predictive maintenance and diagnostics. So electric vehicles equipped with V2N capabilities can transmit data to cloud-based systems for predictive maintenance. This data includes information on battery health, motor performance and other key components. AI algorithms analyze this data to predict potential issues before they become serious problems, allowing for timely maintenance and reducing the likelihood of breakdowns. So the next is vehicle to grid communication, V2G. So V2G communication is a transformative aspect of V2X that allows electric vehicles to interact with the power grid. It enables bidirectional energy exchange, meaning EVs can both draw power from and supply power back to the grid. So under this, first one is the grid stabilization. So EVs can act as mobile energy storage units that help stabilize the grid, especially during peak demand periods. V2G communication allows EVs to feed excess power back into the grid, reducing the need for additional energy production from non-renewable sources. This capability supports grid stability and promotes the use of renewable energy. Next one is peak load management. So V2G technology enables electric vehicles to charge during off-peak hours when electricity is cheaper and demand is low, and then discharge electricity back to the grid during peak hours when demand is high. This approach not only benefits the grid but also offers economic incentives to EV owners who can sell back electricity at higher rates. So the next is home energy management. So EVs with V2G capabilities can be integrated into home energy management systems during power outages, or when electricity rates are high. EVs can supply power to the home, providing an alternative energy source and reducing reliance on the grid. This integration also enables better utilization of renewable energy sources like solar power by storing excess energy in EV batteries for later use. So the next is support for renewable energy. So the V2G technology supports the integration of renewable energy sources like wind and solar into the power grid. By using EVs as distributed energy storage, V2G helps manage the intermittent nature of renewables, storing excess energy when production is high and supplying it back when production is low. This facilitates a cleaner and more sustainable energy ecosystem. So, dear learners, now we will discuss the challenges and future prospects of V2X in electric vehicles. So, while V2X technology holds immense potential for electric vehicles, several challenges need to be addressed for its widespread adoption. So, first one is the technical and regulatory challenges. So, interoperability. So, ensuring that different V2X systems and components can work together seamlessly across various manufacturers and regions. Next one is the data privacy and security, protecting sensitive data exchange between vehicles, infrastructure and networks from cyber threats. Next one is the regulatory frameworks. So, developing global and regional standards and regulations to govern V2X communication and ensure safety, reliability and fairness. Next one is the infrastructure development. So, investment in smart infrastructure. So, significant investment is needed to upgrade existing infrastructure such as traffic signals and road signs to be compatible with V2X systems. Network coverage and latency. So, ensuring widespread coverage and low latency for 5G networks, which are crucial for V2X communication. Next one is the adoption and public awareness. So, in this, consumer acceptance. So, educating consumers about the benefits of V2X and ensuring user-friendly interfaces and experiences. Automaker commitment. So, encouraging automakers to integrate V2X capabilities into new electric vehicle model and collaborate with technology providers and government to drive adoption. So, dear learners, to conclude this lecture, we have discussed the vehicle to everything V2X, which is a transformative concept that has the potential to revolutionize the electric vehicle sector by enabling safer, more efficient and interconnected mobility. With advancement in communication technology, the integration of V2X in EVs can lead to significant improvement in road safety, traffic management, energy efficiency and user experience. While challenges remain, the future of V2X in electric vehicles looks promising as technology, infrastructure and regulations evolve to support this new era of smart mobility. So, dear learners, in this lecture we have discussed about the role of artificial intelligence in the EV sector and also a very new concept of vehicle to everything denoted by V2X. So, I hope this lecture will help you to deal with some more topics related to EVs. So, till then, happy learning and thank you for your patience. We will meet in the some next upcoming lectures. Thank you.